Okay. So in previous modules we discussed so many problems. Yes. So next one, page number 92. Try these problems. First one, the square of which of the following numbers would be an odd number or an even number? Why? Okay, that is our question. So before entering solving these problems, we want to know two properties we have already discussed. Yes, in previous modules. First one, if a number ends with 0, 1, 4, 5, 6 or 9 at its units place, the square, that is, it is a may or may not be a perfect square. Okay, that is the property of a square number. First one. Second one, square numbers can have only even number of zeros at the end. Okay, 40 is not a perfect square but a 400. 400 is a perfect square. 90 is not a perfect square but 900 is a perfect square. So even number of zeros ends. So that is a perfect square. Clear? Then the third one. 1 square 1. 2 square 4. 3 square 9. 4 square 16. Okay, etc. Next one. 11 square 121. 12 square 144. 13 square 169. 14 square 196, etc. So the third property is that the square number of even numbers are always even number. 2 is an even number. What about its square? Again an even number. 4 is an even number. What about its square? 4 square? 16. So it is again an even number. So square one number, that is square of an even number is always an even number. Square of an odd number is always an odd number. 1. It is an odd number. What about its square? 1. 3. It is an odd number. What about its square? 9. It is again an even odd number. Okay. So square of an even number are always even number. Square of an odd number are always an odd number. Clear? So we can say here our question is what? What about what is the question? 727. What is our question? The square of which of the following numbers would be an odd number or an even number? The square of 727. Whether the square of this number, whether it is an even number or odd number. This one, 727. It is an odd number. Okay. What about its square? 727. It ends in 9. 7 sevens are 49. So it is again an odd number. Clear? Then next question. 158. 158, 8. So it is an even number. Even number. What about its square? 158 square. It ends in which number? 8 8s are 64. So ends in units place is 4. So again an even number. Okay. So what is the conclusion? The square of an even number are always even number. Square of an odd number are always an odd number. Clear? That is the concept of this type of question. Next one. What will be the number of zeros in the square of the following numbers? Okay. So 60. The number of zeros at the end, 60 is what? 60. Only one zero. So it is not a perfect. The zeros ending this one is 0. Only one zero. So we can say that what that is it will be. So what about its squares? That is 60 square. 60 square means 6 6 are 36 and 2 zeros are there. Okay. 1 zero in one number. What about its square? 2 zeros are there. Next one. 400. Already here it is 2 zeros. So its square number have 4 zeros. Okay. 400. into 400. Okay. So 2 here, 2 zeros, 3 zeros. So 64 zeros are there. Okay. That is our problems. Clear? So our question is what? What will be the number of zeros in the square of the following number? 60. Only 1 zero. What about its square? Have 2 zeros. 60 into 60, 2 zeros are there. There are already 2 zeros. So what about its squares in the number? That is 4 zeros are there. So that is the second property of a square number. Square numbers can have only even number of zeros at the end. Okay. These are the problems in this chapter. Okay. Next one. Please listen. Please take your textbook. That is. So up to try this. That is page number 92. From some more interesting patterns. That is no need. Okay. So I will start from page number 97. Finding the square of a number. Okay. So exercise 6.1 is a deleted portion. That's why. So finding the square of a number. Okay. That is the important one. Finding square of a number. So without actual multiplication, okay, 11 into 11. Already we know that it is 121. So without actual multiplication means what? 11 into 11. So we are doing like this, no? 1 ones are 1 here, 1 1. So we get 120. So without actual multiplication, how to find the square of a number? Okay, we want to calculate 53 square. How will you do? That is 53 into 53? No, it is the actual multiplication. So without actual multiplication, how to calculate square of a number? So for using algebraic identities. Okay, all of you know that a plus b whole square is equal to what? A square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. These two identities is used for solving these type of problems. Clear? So how to solve these type of problems? Okay. So next our portion is what? Page number 97. Finding the square of a number. That is without actual multiplication. Okay. So first question 23. We want to calculate 23 square. No need to calculate 23 into 23. So we use here 23 can be written as 20 plus 3. Okay. So 23, 20 plus 3. Okay. So nearest to 20, no? So 20 plus 3 is 23. So we can write here 20 plus 3. Next we want to calculate its square. So 23 square is equal to 20 plus 3 whole square. Okay, it is a form of first identities. What? A plus b whole square is equal to a square plus 2ab plus b square. Okay, first one. Here a, here b. Okay, what will you get? A square 20 square plus 2 into ab. ab here 20 into b, here it is 3. Okay. Plus b square, that is 3 whole square. 20 square, all of you know that 2 into 2, 4. 1 0 is there. So its square have 2 zeros are there. So 400 plus 2 into 20 is what? 40. 40 into 3, 120. Plus 3 square, 9. Add it. 400 plus 120, 520. 520 plus 9, 529. So, this is the square of this number. Okay. So, without actual multiplication. Without multiplication, no. Here we use multiplication, no. So, without actual multiplication. Actual multiplication means what? Here we use, no. 23 into 23. Let us check. Okay. 23, here it is 529 or not. 23 into 23. 3 3s are 9. 2 3s are 6. 2 3s are 6. 2 2s are 4. 9 12, balance 1, 5. This is the actual multiplication. So, without actual multiplication, how to find square of a number using algebraic identities? So, here we should study a plus b whole square is equal to a square plus 2ab plus b square, and the next one is a minus b whole square. Okay, so a square minus 2ab plus b square. Clear? Okay, so this is the problem. Okay, so this type of problem is very important. So first, how to find that is a square of a number using algebraic identities, these type of problems. Okay, next we discuss another modules. Okay, I think it is